Hello friends, I'm Dr. Sumna. So here today we are going to do a quick recall of the PSM questions asked in the INICT May 2026 examination. Okay. So before going into the questions, we'll just have a quick analysis of which all questions came from which all chapters. So in effect, totally we had almost 12 questions from community medicine, which is actually lesser than what we used to get in the previous years. But the 12 questions that were asked were, I would say, kind of moderate to difficult level questions. Like direct factual questions were not there. All the questions asked were conceptual. So only if you know the concepts, you would be able to answer these questions properly. But again, most of the questions, like at least 50% of the questions from community medicine came from the repeatedly asked or the previous year topics only, but the question were kind of twisted, and it was more of application level questions than directly asking you the fact. Okay, so we had majority of questions coming from epidemiology. 5 out of 12 questions was on epidemiology, 2 from vaccine, and that 2 conceptual questions. 1 question each from health program, screening, infectious disease epidemiology, family planning, and sociology. But unlike the usual trend of questions coming from biostatistics, this time we did not have any question from biostats, as well as health programs also we had only one question. Usually we have more questions. Okay, so with that we'll go to the question discussion. First, we'll discuss the questions from epidemiology, followed by the rest of the chapters. Okay, first question from epidemiology that we are going to discuss is, so this is a study assessing the association between smoking and lung cancer, and they've given the data. Out of smokers, 80 were deceased, 40 were not deceased. Out of the non-smokers, 20 deceased and 60 non-deceased. So the question was to calculate the odds ratio. So this is a direct question, calculation question. First thing, case control study, draw the 2 by 2 table. So all these values have been given in the question. So whenever you're drawing the 2 by 2 table, the truth is always on the top. So what's the truth here? Those who actually have the disease and those who do not have the disease. So that comes on the top. On the sides, it's the exposure status, smoking and non-smoking. And then when you fill in the the values, what is odds ratio? Odds ratio is nothing but the cross product ratio. So AD by BC. So when you compute, you get the answer as 6. So the answer for the first question was option number C, which is 6. That's a direct question. Just have to draw the 2 by 2 table and compute and write the answer. Okay. Next question is a conceptual question, and this is basically testing whether you know the concept of population attributable risk. Okay, let's see the question. So, in a community-based study, researchers found that a large population of stroke cases were attributable to hypertension. So, which is the exposure, which is the outcome? Hypertension is your exposure, and the outcome is stroke. Okay, so the researchers found that yes, hypertension was associated with the outcome of stroke. So they concluded that controlling hypertension could reduce the burden of stroke in the population. So the question is saying you are controlling the exposure, and this reduces the burden of the outcome in the population. This is exactly the concept of option C, that is population attributable risk, right? We'll see it once more. So in this question, any research you do in epidemiology, you have an exposure, you have an outcome, right? So here the exposure is hypertension, the outcome is stroke. And since it's a cohort study, we can calculate different types of risk. You can have the relative risk, you can have the attributable risk, you can have the PAR or population attributable risk. What's a relative risk? It's basically the strength of association, or it is got from the formula incidence in the exposed divided by incidence in the unexposed. For example, suppose in this particular example, the relative risk is 2. How do you interpret it? It means that the hypertensive people have 2 times more risk of having the stroke, or people in the exposed group are having twice the risk of developing this particular outcome. That is your relative risk. Okay. Now, attributable risk is what is the excess risk of the outcome among the exposed people, or here, what is the excess risk for developing a stroke among the hypertensives? That is your attributable risk. And finally, your population attributable risk is what proportion of the stroke cases in the total population can be attributed to your exposure, or in the total population, what proportion of the outcome is because of the exposure. So the key word there is the total population. That becomes the population attributable risk. I hope that is clear to you. Suppose the population attributable risk is say 60%. That means 60 percentage of the stroke cases. So it is 60%. That means 60% of the stroke cases in the population are attributable to this particular exposure, which is your hypertension. Okay, that is the meaning of population attributable risk. Now, the same concept only. So, you have a population. Out of that, some people might be exposed, some might be not exposed. So, the risk because of your exposure among the exposed people gives you the attributable risk, and the risk because of this particular exposure among the whole population, which means they have population will have exposed as well as unexposed people, right? The risk because of the exposure in the total population is what we call as the population attributable risk. So, this is a beautiful question directly checking whether you know the concept of population attributable risk. I hope you got it correct. Moving on to the next question. This is a simple question, always repeatedly discussed question. So they've asked you to basically identify the study design. Question is researchers compare per capita alcohol consumption and prevalence of liver cirrhosis across multiple countries. This is the catchword here. Okay. Positive correlation was observed, which is the study design. So here the unit of the study is population, right? The unit of the study is not a person, it's not an individual, it's not a patient, but it is country. Different countries are taken as the unit of the study. This kind of study is what you call as the ecological study, right? So answer would be option C, ecological study. Quick recap. So in the question they've given, they're comparing the alcohol consumption and the prevalence of cirrhosis among different countries. So the unit of study is of population. So the study design is ecological study. And what is this ecological fallacy? It's not asked in a question. I'm just telling you because this is also a likely question in the coming up examinations. So, in ecological studies, what we are doing, you are actually interpreting it for the whole country. So, if I get that higher alcohol consumption in a country has leading to higher prevalence of liver cirrhosis, I'm actually generalizing it to the whole country. But suppose when I take the individual units, or if I take the individual people in that country and assess, this relation that I got might not be true. So, whatever you are generalizing for the whole population or the whole country might not be true for the single units in that particular country. This is called as ecological fallacy. This is one of the limitations of your ecological studies. Okay, moving on to the next question. So next question was based on a nested case control study. So it's an assertion reason question. Yes, we are back with assertion and reasons. This time INCT has asked you assertion reason question, which is not a favorite of the students, but again, you should know that. Okay. So what's the assertion? So they're saying that nested case control studies provide a better estimate of association than conventional case control studies. Do you think it's true? Yes, it's absolutely true. Why? What's a nested case control study? Basically, you have a bigger cohort study going on. Okay, so you have the exposed, you have the unexposed people. You're following them up for a period for a longer time period, and in between, you get people with cases. Your exposed or unexposed people can develop disease in a cohort study. So you decide to do a case control study within that bigger cohort study. So what you do, you get cases in that cohort, you pick them up, and for each case you select a matched control. So then you get certain cases, you get certain controls, and then you can do a case control study embedded within the bigger cohort. So this is far better than your conventional case control studies. Why? See, one of the major issues with case control studies is recall bias. But when you're doing it within a cohort study, it has a lesser chance of recall bias. That is one thing. Second thing, any cohort study you do, we take the baseline data initially, right? So even in this case, since the study is embedded within a cohort, you have the baseline data with you. So that itself will reduce the chance of bias, and also you get a better inference. So hence you can say that nested case control studies are a better estimate or are better or superior to your conventional case control studies. Reason they've given us the studies are derived from a cohort design. Yes, that's why you call them as a nested case control study, right? And the incidence can be measured. So I think this assertion and reason are correct, and assertion is actually the reason is the correct explanation for this particular assertion. So our option A would be the better answer here. So this is a nested case control study. We have a defined cohort, and whenever somebody develops a disease, you take them as the cases, and at the same time, simultaneously, you choose a control from the same cohort. That is a control of somebody who does not have the disease, and finally, you do the analysis. So this is called as a nested case control study. Moving on to the next question. This question was from meta-analysis. The question is, why is assessment of heterogeneity important in meta-analysis? Options were it evaluates the variability among included studies, directly detects publication bias, automatically removes confounding, helps calculate incidence rate. See, the answer here is option A. Meta-analysis assessment of heterogeneity is important because it helps to evaluate the variability among included studies. Okay, so what is this meta-analysis? You know, meta-analysis is a study designed when you're taking the evidence pyramid, it occurs the topmost portion. Basically, what you do is you have different studies, right? So you combine all these different studies on a particular topic. Say, if I want to find out, if I'm doing the study on prevalence of anemia, and I'm doing a meta-analysis, a systematic review and meta-analysis, I collect different studies which have done the prevalence of anemia among adolescents. Say my study group is adolescents. Okay. So I collect different studies from across the globe. I analyze them together, I review them, and then after some sort of statistical processes, I come at a pooled effect that is called as a systematic review and meta-analysis. So the heterogeneity of the studies, because I'm just comparing different studies. Okay, so that is something which has to be taken into mind or consideration, and that assessment will help us to evaluate the variability among the included studies. Okay, so these three, this is not there in this particular INICT, but these are also potential questions since they have reached heterogeneity. Next would be the limitations in meta-analysis. So what you see on screen, both these three are the limitations of meta-analysis. First, you see ego. What is that? That is garbage in, garbage out. These are all the limitations of meta-analysis. Okay. Ego means garbage in, garbage out. Simply, if you're putting in garbage, then you get a garbage result, right? So if I'm adding garbage studies into the meta-analysis or into the systematic review, my overall outcome or my interpretation is also going to be garbage. So if I'm, or in other words, if I choose studies which do not have a robust methodology, which has not done proper analysis, the study was conducted in a false way. If I add such studies, my final outcome or the final result I'm going to get in my SRM is also going to be a garbage. That's the first thing. Second one is what you call as the apple and oranges effect. What is that? See, I told you we are combining the result of different studies in a SRM, a systematic review and meta-analysis. See, apples are fruits, oranges are fruit, right? But both are not the same. So when you mix them up, you get a completely haphazard thing. So this is called as apples and oranges effect. So when you're choosing completely heterogeneous studies with complete difference, you cannot just combine them per se. That will lead to this apple and oranges effect. Now the last one is what you call as the file drawer effect. This is called as the file drawer effect. What is that? See, I told you in meta-analysis we are choosing different studies. When you take a topic and when you see the published literature, you can see that the studies which had positive results or which gave a significant result had a higher chance of getting published compared to the studies which have negative results or which were not significant. So all the negative result or non-significant studies goes into the draw of the publisher. He's not going to publish it. But the studies which come up with positive results get published faster. This also can cause a bias in your final interpretation of the meta-analysis. This is called as the file drawer errors. These three are limitations of meta-analysis. Has not been asked in this particular exam, but it's a likely question in the coming up exams. Okay. Moving on. So, five questions we discussed were from epidemiology. The sixth question is from screening chapter. They have given you different values, a scenario, and you have been asked to calculate the PPV or positive predictive value. So, a screening test was evaluated in a population of 1,000 individuals. Out of 100 people who truly had the disease, 90 tested positive. Okay, and that's a true positive is 90. Then, additionally, 50 individuals without the disease were found to be positive. That's a false positive. What is the positive predictive value? As usual, draw the 2 by 2 table. Again, truth is always on the top. So the diseased people will come on the top. Here you have the non-diseased people. And this side you have your test result. Those who are test positive and those who are test negative. And you have been asked to calculate the what? The positive predictive value. What is positive predictive value? That is out of the whole tested positive, how many are actually positive. So it is otherwise the predictive value is called as the diagnostic power of a test. That is, if your test is having so many people are positive as per your test result. So out of those, how many are actually having the disease? That is your positive predictive value, or how correctly your test is predicting the result. That's a positive predictive value. You get it from the formula total positives divided by test positives. That is total positives by true positives plus false positives. So true positive by true positive plus false positive, or true positives out of the total test positives will give you the positive predictive value. If you compute, we get the answer as 0.64, that is 64%. So the answer here would be option B, 0.64. What is the other easiest way to to calculate the positive predictive value, sensitivity, specificity, and negative predictive value from your 2 by 2 table? I hope you know this easy shortcut. See, I just draw from here. This is my center. Okay, I take this the true positive as a center point and I draw a line like this. I draw a line like this. This line will give me the sensitivity and this will give me the positive predictive value. Similarly, if I start from the true negative, that's the fourth square, and if I draw a line below, that will give me the specificity, and towards the side, what will be? Is the negative predictive value. Let's write it down. So sensitivity is what? True positive, that is the numerator, divided by this line. So that is true positive plus false negative. Similarly, the positive predictive value would be again the numerator is the same. That is from where you started. So true positives divided by true positive plus false positives. Similarly, specificity would be true negatives divided by this. So that is false positive plus true negative. And negative predictive value will be true negatives divided by the line is like this, no? So false negatives plus true negatives. So this is an easier way to calculate all these sensitivity, specificity, and the predictive values if you make the 2 by 2 table. Okay, next question is from vaccines. Now we have two questions from vaccines. We'll see that. First question is basically checking whether you know what you mean by vaccine efficacy and effectiveness. So what is efficacy and effectiveness? See, efficacy is the protection a vaccine can offer in ideal conditions, in ideal your laboratory conditions where you are keeping everything to the point, to the notch. So you're arranging everything. It's an ideal, it can be an RCT. In an ideal condition, what protection your vaccine is giving, that is measured by the efficacy. But when you, after all the trials, when you actually release this vaccine into the public, you start giving the vaccine in the vaccination programs, you're going to encounter different real world issues like there might be logistic problem, the cold chain issues can come, people might be hesitant to take vaccines, some reactions can occur, some unknown or unexpected issues can come up, right? So, in the real world, what is the protection offered by this vaccine is measured by the effectiveness. So, efficacy is basically under the trial or the simulated conditions, and effectiveness is the protection offered in the real world. Okay. With this knowledge, let's see the question. So, a newly developed vaccine was reported to have efficacy of 90, effectiveness of 85. Which are the correct statements? Vaccine efficacy refers to protection under ideal clinical trial conditions is correct. Vaccine effectiveness refers to protection under real world conditions is also correct. Effectiveness may be lower than efficacy is of course correct because effectiveness is in real world conditions, my dear. So you are going to face different problems. So that will be a lower value than the ideal efficacy. Now, what is option C? Vaccine provides complete protection. No, you don't have a vaccine which protects you 100%. We are trying to have that, but as of now, we don't have any vaccines which give complete protection. So that will be a wrong statement. So here the correct statement would be A, B, and D. So option B, that is A, B, and D would be the better answer here. So, quick comparison between what you mean by efficacy and effectiveness. So, vaccine efficacy is the protection offered by the vaccine under ideal conditions, example in an RCT, whereas effectiveness is protection under real world conditions, like you get it in field studies or population studies. And the setting is usually experimental in vaccine efficacy and a community setting or a practical real world setting in effectiveness. So the example would be, COVID vaccine would have shown 95% efficacy in trial. But when the same vaccine was introduced in the community, what happened is it showed a lesser protection, that is 85 to 90% was the effectiveness. So efficacy is basically to measure the biological performance of the vaccine, and effectiveness measures the actual public health impact of the vaccine. Okay. Next question was from HPV vaccination. HPV vaccination is a recent hot topic. It's a recent update. We just had a HPV vaccination campaign in India. This also has been discussed. So we'll see the question. Regarding HPV vaccination, which of the following statements are correct? Option A, recommended target age group 9 to 14 years. You think it is correct? Yes. HPV vaccination, this is the recommended age group as per the program. Now, option 2, single dose schedule has been accepted. Yes, this is also true. See, when you take the example of the real world HPV vaccination campaign which occurred in India recently in the March, April months, what was happening is all girls at the age group of 14 years was given a single dose of HPV shot, free of cost. This was the campaign. You think they won't give it without recommendations? No, there is several recommendations which says that the single dose vaccine is also effective. We have recommendations from WHO side also. So that is also a correct point. Now, HPV vaccine provides complete protection. That is wrong. No vaccine can give you 100% protection. It protects from cervical cancer, but when they say complete protection, that won't be a correct answer. Option 4 is high vaccine coverage is important for elimination. Of course, yes. You need a good coverage, then only you can have elimination and further eradication also. So answers would be 1, 3, and 4 are correct. Sorry, 1, 2, and 4 are correct. So that is option B. Okay. Few words about the HPV vaccination campaign. So you remember we had a recently, it's still ongoing. So we have a HPV vaccination campaign going on. It protects against HPV and causing cervical cancer. So it's actually a one single dose HPV vaccination campaign. Target age group is girls of age group 14 years. And which is a vaccine given? Is it Gardasil or Cervavac? See, Cervavac is a vaccine which is indigenously produced in India. It would have been good if we were able to give Cervavac vaccine because it is cheaper, it is produced in India and all that. But since we are giving a single dose vaccination campaign, we don't have good data enough to support that Cervavax single dose is sufficient enough. So we are giving Gardasil because we have published literature saying that Gardasil single dose is also very effective. Hence, we have given Gardasil in this particular campaign. But in future, we can expect that we'll have more research findings about Cervavac, and slowly the program will be able to replace Gardasil with our indigenous product, which is Cervavac. Okay, and who produces Cervavac? It is the Serum Institute of India. Now, next question was, it was not directly from communicable diseases, but I would say it was a question from infectious disease epidemiology, which we have discussed under epidemiology only. So they have given you an epidemic curve showing multiple successive peaks separated by approximately one incubation period, suggesting person to person transmission. So they are talking about what kind of epidemic? They're talking about a propagated epidemic, right? There is multiple successive peaks and person to person transmission as is a propagated epidemic. So which of the following diseases shows the pattern? See, staphylococcal food poisoning and salmonellosis. Both these are example for point source epidemic. Like these are food poisoning. So as a single point of exposure and everybody who ate the food gets the disease, and all the cases fall under a single incubation period, or you get a single curve. When you talk about typhoid, it is usually from a common contaminated source. So the graph will be something like this. It will have a plateauing thing. And measles is a typical example for a disease which has person to person transmission, or it's in a propagated epidemic. So answer would be option A. Quick recall about the types of epidemic. We have a point source epidemic from a single exposure. All cases fall in one single incubation period. Then you have a continuous common exposure where you have a plateauing, and ideally it shouldn't be like this. Okay, you will have smaller peaks, but it will finally plateau off. This is a common source epidemic, and you have the thing asked in your question was a propagated epidemic. You have peaks which are going to increase in the height. So taller peaks you will get basically seen in diseases which have person to person transmission. So they are going to the epidemic is going to propagate. That's a propagated epidemic. Examples: measles, COVID. All these are examples for your propagated epidemic. Okay. Now, next question. The only question we got from health programs. The program asked was RMNCH plus A. Ideally, the name should be RMNCAH plus N. N for nutrition, right? So, under the RMNCH plus A strategy, certain districts are identified as red flag districts using selected indicators. Which of the following are considered as red flag? So, even if you don't know the concept of red flag districts, this question is quite simple. So, it's even given you certain indicators. Which of these are considered as red flag? That means which of these are not good. First option, TFR, more than 20% above national average. It is definitely a red flag. What is TFR? TFR is the total fertility rate. Basically, you can say it is like, average number of children a woman would have in a lifetime. And the replacement level of TFR is 2.1. So that a replacement level is, we are just, a female is just replacing herself. Okay. And if the TFR is going above that, you are going to have population explosion. We don't want that. Our family planning program is trying to reduce the TFR or keep it under the replacement level. So option A is definitely a red flag. Option B, IMR significantly worse than national average. IMR is kind of showing your infant mortality rate is a proxy, indicator showing the socioeconomic development of a country. Or if it is worse, that means it's a Obviously, it's a red flag. Next one, low healthcare seeking for ARI. That is also a red flag. ARI or pneumonias, these are one of the most common cause of morbidity and mortality in under 5 children. So if there is low healthcare seeking, definitely you're going to increase the mortality and morbidity, right? Last one, poor maternal health indicator is also definitely a red flag. So option would be A, B, C, D. So even if you don't know about RMNCH plus A further, these, if you know these indicators, you can easily answer this question, right? Now, next question was from sociology about the components of attitude. The correct question was basically what are the components of attitude? I think that is the question. So, answer would be A, B, C. You see, attitude is how you feel, and the components are A, B, and C. That is affective, behavioral, and cognitive. So, that is the answer. Option A is the correct answer here. So, attitude, this is a park definition. Attitude is a way of thinking, feeling, and behaving towards anything. It can be towards some person or some situation or an object or anything. Okay. It has three components. Remember A, B, C. Affective component, which is how you feel or the emotion part. Behavioral component is how you are going to act or respond. And cognitive component is the knowledge part. So, these are the three components of attitude A, B, and C. Last question was from family planning. This was a very easy direct question. Define Pearl Index, right? Everybody knows this. So Pearl Index is basically measuring the efficacy of your effectiveness of your contraceptive, and it gives you the number of accidental pregnancies per 100 woman years of exposure. The answer would be option B, should be actually number of accidental pregnancies. So somebody is using a contraceptive, and in spite of using that particular contraceptive, if they get accidental pregnancies, that measure is the measure of Pearl Index, right? But you cannot measure Pearl Index for each and every person. So when you're talking about a index for a common contraceptive, how you measure is you measure the total number of accidental pregnancies in the women who have been using this particular contraceptive. So definition wise, it is the number of accidental pregnancies occurring per 100 woman years of exposure while using a particular contraceptive. So if your contraceptive is very good, you have a very low Pearl Index. And if your contraceptive is bad, then you have a very high number of accidental pregnancy. Your contraceptive is not working, right? Or a higher Pearl Index. Now, when you write down the formula, if it's a calculation based question and if they've given the exposure in terms of months, your formula becomes number of accidental pregnancies by total month of exposure into 1200. This 12 is for, you know, when you convert it into months. Or simply, when you say Pearl Index is the accidental pregnancies per 100 women years. Okay. So these were the questions asked in the INICT May 2026 exam. So from this, one thing is clear: if this is going to be the pattern in the coming up NEET exam or your FMG or the further INICT exam, it's not just mugging up. Okay, you can't just rely completely on mnemonics, one-liner, short notes, and mugging up things. No, basically the exams are testing whether you know the concept. So you have to be ready with a good understanding, simplified and good understanding of the logic behind each of these chapters, whether it is epidemiology, biostatistics, and also most of the questions will be clinically correlated. So it's like a application level of questions. So it's like I would say it is applied public health that was tested this time rather than your memory based community medicine. Okay. With that in mind, let's keep learning, keep revising for your upcoming exams of NEET PG, INICT, FMGE. So all the best and thank you for listening.